the research is the working prototype. And I have a demonstration session about the working prototype. If we have time to go there briefly to see how it works. But the prototype implementing the standard prologue, more specifically HCI prologue, the Java interface prologue, developed by Jericho in 2008. Actually, it's for a long time before, but the new release in 2008. The program is based on the technical model checking developed by Wilson and Marshall in the year 2000. But this kind of technique has been developed for the phase transition work. What I do here is I modify the algorithm a little bit to work with battery net, and I combine certain operator like non or do operator and so forth. The detailed explanation of what I do with the program has been explained, I think it's in chapter 7. And the second thing is that a program that gets the result from model checking and generate the control requirement. The advantages of the approach compared to other approach in the automatic analysis of control is that I try to maintain the theoretical rigor of the representation and the plausibility and extensibility of the implementation. So in this approach, if you can model, if you can describe a control principle in the form that I provided before, including a temporal formulas and a control obligation, then you can add into the system without modifying the program. This is the key issue. Yes, all of the components of the program have been defined rigorously. The algorithm, I provide the semantics of the algorithm in chapter 7 of the dissertation. The validation, I validate the result in 3 criteria. The first criteria is the theoretical rigor of the research. For every component, for every notation used in the dissertation, I provide the formal syntax and formal semantics. And then the computability, as I just told you, a control rule can be implemented naturally in program. You see the control rule in formal form and in the implementation form is nearly the same. And the same way, you can look at the dissertation, you see the implementation of a Deontic factory net is naturally in program.
Well, let me just make a simple comment. It's a word of computability is not the right word to use. In computer science, that means something what is computable, what is not computable. This is more like what is implementable, reliable in computer terms.
Yeah,
implementability.
Yeah, implementability.
Yeah, I was thinking that when you said that the first time.
Right.
I wanted to know what that can was going to go with that.
Sure. That's what sounds very familiar for me. Maybe it's in here. Maybe. Yeah, thank you. Yeah. The most important thing is the practical relevance. I do the 14 test cases of international payment procedure of the 2 famous payment procedures used in international trade, especially the documentary credit procedure. This accounts for like 70% of the payment transactions used in international trade. And I built many different scenarios, including contracting, that means how the people come together to establish various contracts involved in the documentary credit. In a documentary credit, there are multiple parties involved in the transaction. The seller, the buyer, the issuing bank, the advising bank, the informing bank, negotiating bank, and so forth. So there is a network of contracts, a sale contract between the buyer and the seller, a credit contract between the buyer and the issuing bank, and a confirmed contract between the confirming bank and the seller, and so forth. There's a network of complicated contracts. So in the dissertation, I have present the validation based on examination of scenario of the establishment of the contract, as well as performance of the contract. And the result of that is 14 scenarios as I see here. That means from 2 procedure, and we consider various situations, come up with 14 different scenarios. And the results show that all of control requirements stipulated in the procedure by the International Chamber of Commerce would be derived automatically by the method provided here. So the key thing is that I model the underlying deontic process of these two procedures in different scenarios and generate control requirements. And use the result to compare again the detailed control requirements stipulated by the International Chamber of Commerce, the organization that issue standardization and convention for the procedure. The disappointing thing is that all of the results show that all of the control requirements stipulated in the procedure can be derived by the method.
So it would be, excuse me, it would be interesting to have some data
Yes.
to test, actually test the scenarios against.
Yeah, sure. We have the demo.
It's difficult to have the data sets.
Right.
And so what you're saying here is that you've tested 14 scenarios, and by extrapolation, the whole thing works?
Maybe it's
Am I
not the
missing
whole
the-
framework.
Am I missing, am I restating that correctly?
Okay. Yeah, let me explain again. Maybe I'm not clear enough. Okay. So the test case here, I use two international payment procedures. That's the cash in advance and documentary procedure. There are two payment procedures. For one procedure, there are many different scenarios. The procedure may be in documentary credit, for instance. You may have a confirmed documentary credit. You may have a non-confirmed documentary credit, and so forth. There's different situations or different specific cases, right? And come up with the specific cases, the 14 scenario. Each scenario is a specific situation. Right. In each of the specific situation, the International Chamber of Commerce specify a set of requirements, what the seller needs to do, what the buyer needs to do, what the buyer needs to do, and so forth, step by step.
Okay. So all the control requirements for those 14 scenarios are derived automatically?
That's right. Can be derived automatically by the method.
You might want to rephrase your result part there slightly.
Because
Right.
the way it's stated, it kind of looks like you're doing case studies. And that's not,
That's
what
not
you're
what you're
looking
doing.
at here
Yeah.
is, when you say scenario, what you mean is, the functionality of, there's different modes of cash in advance. And what you're doing is you're using your program to derive the control requirements.
Yeah.
And you're comparing it to what the ICC
Say.
recommended as control requirements.
Yeah.
And you come up with all, is it an exact match, or do you come up with more than they do, or less than they do?
Cover. I mean, I come up more. I will explain a little bit more detail in the demo. The thing is,
So this is kind of like you're comparing, you're taking the ICC as a set of experts.
Yes.
And in some sense, you're testing your
method.
expert system against the
right.
ICC.
The thing is,
Right.
the thing I come here is what they say by the expert, and here is what I come up. I come up more. I will explain a little bit in the next couple of the slides in the demo.
You also might want to limit your result statement to saying everything for those 14 scenarios is...
Well,
Exactly.
let me ask a question here. So when you say these control requirements, where do you derive your formalization? How do you come up with your formal model? Based on what?
The formal
You
model.
mentioned the Deontic or whatever, but those are those part of the requirements themselves?
Yes.
You can't just come up with a formula without that
Yeah,
basis,
sure,
right?
sure,
So
Sure. Like I just say, in order to do, I come up with a Deontic process model. Deontic, sorry. This is to model the underlying purpose of the transaction. And in order to model that, we need to knowledge from the contract law, from the regulation that govern the transaction, and so forth. This requires expert knowledge. Here what I do is I look at the ICC guides, that is the law for international documentary credit, and I come up with what is the movement of obligation of the seller, the buyer, and so forth, sorting out the control. What is the obligation, the underlying obligation of the buyer, the seller, the bank, and so forth, okay? And come up with a Deontic process model.
sure, in software engineering,
Yes.
Okay.
Yes.
So what's given basically from user are called the user requirements.
Yeah, this is the user
Okay.
requirement. This
That's right.
is user requirement.
And then you build a model we call specification.